Okay, this is project test number 2, and this is video 3, and we'll cover problems 21 to 30. So Dan selected a random sample of 100 students from the 1,200 at his school to investigate preferences for making up school days lost due to emergency closings. The results are shown in the table below. So basically, we had 58% who said extend the year in the summer, and 42%, 42 out of 100. So 58 out of 100 and 42 out of 100. Okay. And by the way, how many samples did Dan take? He took a random sample of 100. So we have one sample. This is going to be proved to be very important. Dan incorrectly performed a large sample test of the difference in two proportions. Whoa, he did a sample difference of two proportions. To do that, you have to have two independent random samples. And he calculated a p-value of 0.02. Consequently, he concluded that there was significant difference in the preference for the two options, which the following best describes his error. Okay, so a one sample test would be more appropriate because he only took one sample. He ran a two sample test, a test for differences. So he did P1, P hat 1 minus P hat 2, and he couldn't do that. He needed to do P hat minus P naught. All right. Excuse me, P hat minus the P naught. That's what he should have been doing as for the numerator. So this should have been a one sample test because he only took one sample. All right. All right, number 22. So we have fertilized and unfertilized, and the figure above summarizes the heights in centimeters of approximately 400 pine seedlings 6 years after they were planted at a Center for Environmental Study. Approximately half the trees were fertilized yearly, and the remaining were never fertilized. Which of the following statements about the medians and interquartile ranges of the heights of the group's trees is true? So here we have median. We also have a median. This from here to here is an IQR. And from here to here is the IQR. So since I know we're comparing them and I kind of know where this question is going, I can say fertilized IQR is less than the unfertilized IQR. In other words, this one right here is wider than this one right here. And when it comes to the median of the fertilized is greater than the median of the unfertilized. And I know that because this one is below that one. And when I read the answer choices, the median for the unfertilized is less than the median for the fertilized. And the IQR is greater. IQR is greater for the unfertilized. The IQR here is greater than this one. So my best answer is number 22, D. All right, on to number 23. In a certain school, 17% of the students enrolled in a psychology course, 28% are enrolled in a foreign language course, and 32% are enrolled in either a psychology course or foreign language or both. What is the probability a student chosen at random from this school will be enrolled in both a foreign language and a psychology? So basically they're saying, hey, you know what, you're going to need to use this formula. Probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. Now I'm going to put this in terms of our problem here. So we have the probability of psychology union the probability of foreign language equals the probability of psychology plus the probability of foreign language minus the probability of psychology, and foreign language. So normally this phrase means and. This phrase uses normally or. So let's try and figure out what we have. 17% are enrolled in psychology. Well, that's easy. That's 0.17. 28% are enrolled in a foreign language course. Okay, that's easy. This is 28% go to foreign language. Then we have one more value. And 32% are enrolled in a psychology, or that lets me that it's probably here, foreign language, or both. So in other words, in all of the above, either this or this or this. And they don't always have to put the both in there. If they use or, this is what they're referring to. So they put the or and they're saying, all right, this is 32% are in both. And then just for clarification, both foreign language and psychology, which, and here we just have both. We have just psychology and just foreign language. And this is a term we use for and then use this as a clarifier right there. So this is what I'm looking for, is I'm looking for this value, and I'm just going to call it X at this point. I sum these to get two together, and I get 0.32 equals 0.45 minus X. I'm going to subtract 0.45 from both sides. And I got negative 0.13 equals negative X. Make them both positive. We're all nice and happy. And we get D for our answer. Monthly rent, number 24, was determined for each apartment in a random sample of 100 apartments. The sample mean of 820 and the sample standard deviation was $25. And a approximate 95% confidence interval for the true mean monthly rent for the population from which the sample was selected was $815 to $825. Which of the following statements is correct interpretation of the 95% confidence level? So they're asking us to interpret the confidence level, which means in repeated sampling, or if we did this in all samples, we expect to capture it 95% of the time. So in repeated sampling is, I'm going to look to see if we have that. Oh, here's one. In repeated sampling, the method produces intervals that include the population mean 95% of the time. I like that. But I also have another in repeated sampling. In repeated sampling, the method produces intervals that include the sample mean approximately 95% of the time. So the only difference here is population and sample. We use confidence intervals to estimate the population. We do not use them to estimate the sample. We know the sample. The sample mean will be in the center 100% of the time, but it's only 95% of the time do we successfully capture the population mean. So we're estimating the population mean, or 95% of the time we expect to get it. All right, truthfully, one of the hardest questions in all of AP statistics right here. Two friends, Andy and Bob, participate in a game of bowling every week. From past experience, it is known that both friends' scores are approximately normally distributed. They're telling us this because we're going to have to ultimately combine them, and if they're normal, we can. Where Andy has a mean score of 150, and Bob has a score of 165. Andy's standard deviation is 30, so Andy has a 150 with a standard deviation mean of 150, standard deviation of 30. Bob has a mean of 165 and a standard deviation of 15. Which of the following, assuming their scores are independent, and that's important because you cannot combine standard deviations. Remember, to combine standard deviations, they must be independent. Which of the following values is close to the probability that Andy will have a greater score than Bob in a single game? Well, first off, we need to find out what we expect it to happen on average. And we can subtract means directly. And if I subtract them directly, I find out that the difference is I expect them to have a mean Andy minus Bob equals negative 15. I expect Andy to lose by 15 points, and that's going to be really important. And here's why, because I'm drawing, if I draw the normal curve of the combined, the expected is negative 15. you don't win at negative 15. You have to get above 0. And I know the 0 is up here because this is the positive, this is negative. So this is essentially a number line. So I need to get to values above 0 in order for Andy to win. Now, it was really nice of me to be able to subtract for the means. But for standard deviations, I can't just subtract. As a matter of fact, I can't subtract them at all. I have to add them. Then but I also have to square them. This becomes 30 squared plus 15 squared. And I need to take the square root of that. And I'm going to go ahead and do that real quickly. So 30 squared plus 15 squared. And I'll take the square root of that. And I get about 33.541. 33.541. So that's my standard deviation of those combined. Now, what I'm looking for is the probability that we get a score greater than 0. So the probability that z is greater than 0 minus, by the way, it's not just a minus, it's a negative 15. Because my formula is, please don't forget it, z equals x minus mu over sigma. Well, we already have a negative 15, so this is going to have a minus 15 over the 33.541. Now, there's several ways to go about this, but probably the easiest way is to go to the calculator and do a norm CDF. And if I do that, I'm going to just go second bars, norm CDF, lower bound, negative 99999. Excuse me, that's not correct. My lower bound is, my lower shaded part is 0. My upper bound is going to go to positive infinity. Not that you can win by that much. My mean, please don't forget the negative sign because it'll mess you up, negative 15. And my standard deviation was 33.541. And we end up getting 0.327 as our answer. So our closest answer to that is letter D, or 33%. Now, that is not the only way to approach this problem, but I think it is probably the best way for you to approach that problem. So we're going to go leave it at that. All right. And once again, one of the most difficult problems, in my opinion, of all of AP Stat problems. Number 26 is one of the easier problems. This is one you always have to get right. So scientists have long believed that linear regression can be used to predict the brain weight of non-human mammals from the body weight. In one study, body weight in kilograms and brain weight in grams of 22 non-human mammals were measured. A linear regression analysis was performed, yielding the output below. So here we have the output. So here, right here, we have our slope value. Here we have our standard error. And by the way, I want to talk to you where that standard error comes from. Just as a reminder, this is going to be 1.096. 1.096 divided by the square root of 22. I hope. Well, something is wrong. So I'm just going to leave that alone for the time being. But this is already, they've already divided the standard error for us. We don't have to do anything with this. So this has already been taken care of. And I'm just going to pause this for a second. Anyway, you can skip that for the time being. So assuming that all conditions for inference were met, which of the following expressions will represent a 95% confidence interval for the slope of the least square regression line? Well, first off, n equals 22. And when we're working with regression, degrees of freedom is n minus 2. So that's 22 minus 2, or 20. So let's go ahead and calculate our t-start. So second vars, inverse t, parenthesis, 1 minus 0.95, close parenthesis, divided by 2. Degrees of freedom are 22 minus the 2 because it's regression. That's the only time we're subtracting 2. And we end up getting 2.086. Well, that didn't help us out a whole lot because I had it every single time. but I did want to remind you that that's where the T-star came from. All right, well, we know our slope value. That's our slope value. So that goes right here, 1.096. And our margin of error is basically, our margin of error is T-star times our standard error. So when we're working with regression, think of B hat plus or minus T-star times our standard error, all right? Or the standard deviation divided by the square root of n, but in this case, they give us the standard error, and our standard error is 0.1308. So this right here, without doing any more work, is our answer, because we just take our standard error, and that is that value right there. All right, moving on to number 27. A certain motel is roughly 20 miles from the entrance to Yosemite National Park. The motel manager wants to get a better estimate of the distance and asks 5 people to each measure the distance to the nearest tenth of a mile using the odometer in his or her car. The manager will use the median of the 5 measurements as the estimate of the distance. Which of the following is not a statistical justification for the manager's plan? So odometer reading should be considered a variable. Yes, when I read the odometer, it can be halfway between 2 numbers. So that is a variable. That's true. The median of the 5 measurements is more likely to be close than a single measurement. The more measurements we take, the better off we are. So that's true. The actual distance should be considered a variable. Whoa. No. The actual distance isn't the variable. The actual distance is some actual value. The actual distance, the number of miles to get there should not vary. So consequently, that's false. That distance didn't change. The way we read our odometer might change. Our odometer may be inaccurate, but the actual distance is what it is, and it's not going to change. It's the true population distance. 28. A marketing and research consultant for a hotel chain hypothesized that men and women differ in their color preference for guest rooms. The consultant shows pictures of rooms decorated with 3 different color schemes to each person in a random sample of 110 men and to each person in a random sample of 90 women. The consultant asked each person to choose his or her favorite color scheme. A chi-square test for homogeneity of proportions will be used to test the consultant's hypothesis. Assuming the conditions for inference are met, which of the following statements is true for the test? First off, please remember, chi-square test of homogeneity is essentially a chi-square test of independence. All right, the thing that is most important here, and this is going to be true for any hypothesis test, the larger the difference, the larger the difference, the larger the chi-square. The further you are away from the claim, the larger the smaller the p-value, the more evidence you have. The further you are away, the more likely you are to reject. Okay, so the farther you are apart, the more likely, the smaller the p-value, and the more likely you are to actually reject. 29. The distribution of heights of 6-year-old girls is approximately normally distributed is important. That means we can use a norm CDF and we can use the empirical rule, etc., with a mean of 46 inches and a standard deviation of 2.7. Aaliyah is 6 years old and her height is 0.96 standard deviations above the mean. So what that means is they're essentially saying, you know what? If the mean were 0, which is my z-score, she's up here at 0.96 because she basically gave us a z-score. And this happens to be Aaliyah, okay? Her friend Jane is also 6 years old, and she is at the 93rd percentile. At what percentile is Aaliyah's height? So I need to convert this into a percentile. Well, remember, percentiles go from negative infinity up to a value. All right, so let's do that. We can do that using a norm CDF, second vars, norm CDF, our lower bound, negative infinity, our upper bound, 0.96, a mean of 0, and a standard deviation of 1. And I press calculate. So Aaliyah is at the 83rd percentile, which means 83% of the population is below her, whereas 93% of the population is below Jane. So Aaliyah is shorter than Jane. Aaliyah is at the 83rd percentile, and she's shorter than Jane because Jane's up here at the 93 percentile, and everyone calls her Giraffe and makes fun of her. All right? It's horrible. Not even right. Sorry, Jane. Maybe meet Tarzan. So for the 3 histograms above, and this is number 30, which of the following correctly orders the histograms from one with the smallest proportion of data above its mean to the one with the largest proportion above its mean? Well, I want to start off with this one just because this is easy. This is reasonably symmetric, in which case the mean equals the median. You're like, okay, so what? Well, that means 50% of the data is above the mean. All right? 50% of the data is above the mean. So this is probably going to be the middle one. So we're probably just looking at these two right here. All right? Because L needs to be in the middle because 50% is in the middle value. All right. So they want, we want to go smallest to largest. Well, this happens to be skewed right. And if this is where the median is, the mean is somewhere up here. Well, half the values are below the median. So that means more than half the values are below the mean, which means less than half are above the mean. So this is going to have less than half above. So J is going to have the smallest proportion above with less than half. Well, that means we're looking at this answer, but let's check out K, because J needs to be first because this has less than half. So looking at K, here we are skewed to the left. And if my median is here, 50% are above it, let's say my mean is here. This means more than 50% are above it, because this is 50%. So more than 50% are above the mean. So more than 50%, so this one's K has more than 50%. This one has 50%. K has more than 50%. This one has less than 50%. So number 30 should be letter B. Okay. And we'll get the next ones in the next video.